हरि करना।
Now it's time to get into the continuous random variables and their probability distributions. So let's take a random variable that's a capital Y, and cumulative distribution function would be CDF. For continuous random variable will become f of y is equals to p of capital Y less than or equals to small y, that's any value. And the most important function for this continuous random variable is probability density function, pdf, probability density function, pdf. So f of y is equals to small f, small f of y is equals to d of derivative of capital F, this the cumulative one only, derivative of capital F of y divided by dy. So here we will be covering derivatives as well as integration. What is derivative? In a simplistic ways, derivative is nothing but the rate of change of anything with respect to anything else. So both are variables. The rate of change of something, the function, that could be any type, that could be any equation. Similarly, with respect to, it could be anything. It could be space, it could be time, it could be temperature, it could be x, y, z, anything. That's what is a derivatives. That's what is a derivatives. So here we derive this, we find the rate of change of this, and then that's what we get. When you convert this back, you'll get an integration of this. So f of y, when you integrate this equation, f of y is equals to derivative of f of y divided by dy. So when you integrate the whole thing, so what you get is integration of minus infinite to infinite f of y into dy, and this one will become 1. Okay, so that's how you get the probability density function pdf from the cumulative distribution function cdf. So obviously, uh, in spite of the minus infinite to plus infinite, you can just replace the limits as a comma b. Then if you do the derivative, because you know that the function of this, the value of f of y is nothing but the derivative of f of y with respect to y, dy. So d of f of y by dy multiplied by dy, so dy get cancelled and d of f of y you will have, and it's nothing but one integration of it, so it will become capital F of y. That's it. In that you can replace the limits. So when you replace both the limits with that, it will become f of b minus f of a. I think if you know derivatives and integration, it's very easy to understand it's very easy to understand whatever I speak, what I'm talking. It will make more sense if you're not afraid of derivatives and integration. So I will make some course for you to make it much simpler. I'll do that, no issue. Anyway, I love mathematics. Okay, so that's what f of b minus f of a. So then probability of y is equals to a is 0. So that's what. Then the probability function, the probability density function that accompanies a continuous random variable. So the probability distribution of a continuous random variable is described by its probability density function pdf, which is denoted by small f of y. So the probability function that accompanies a continuous random variable is a continuous mathematical function that integrates to 1. For example, recall the negative exponential function. In probability, this is called an exponential distribution. Exponential distribution f of x is equals to e power minus x. Similarly, when you do an integration, this function integrates to 1. Let's do that. 0 to integration of e power minus x from 0 to plus infinity. So it's equal to, obviously put it here, 0 to plus infinity, and e power minus x, you replace the x values with the respective values 0 and infinity. So e power minus x is nothing but 1 divided by e power x. So 1, first one is 1 divided by e power 0. Second one is 1 e power minus x. You can just convert into that. So e power 0 1, other one is e power 0, and then 1 by other one will become 0. So e power 0 is 1. So other one will become 0. So totally you got the 1. So that's it. So now the probability that x is an exact particular value such as 1.9976 is 0, because it's a continuous variable. We can only assign probabilities to possible ranges of x, intervals of x. So this is what the representation of it. P of x is equals to e power minus x. That's just one function you can take for the continuous distribution. So P of x is equals to e power minus x. In this case, if you want to have a probability between 1 to 2, in between the limits of 1 to 2, you can directly calculate from the integration only. So integration of e power minus x from 1 to 2, so it's, you can directly calculate. You got it around 0.23, and if you look into the graph, and that's what you'll get it. So that's how the integrations will help you. Basically, it's calculating the area. It's calculating the area. Of course, if you increase the levels of integration, double integration, triple integration, then the purpose varies. You can put it into the vector algebra. You can do a lot of activities. You can work on 3D space, 4D space.